Today, vibration excited by reciprocating and rotating unbalance. So this is the subset of what we have done earlier for the force vibration. If you still remember last week, we're doing the forcing systems. There will be a certain force. In this case, our force is actually this one. Okay, this rotating mass itself will actually cause certain force. Okay, so I would recommend you watch this video. So let's watch this video. So eventually this thing will actually turn. Okay, so so hold on. So as you can see, this thing is turning. So what causes this vibration is actually the middle of this shaft, right, connected right up to here. So when this thing is turning, it will certainly cause a certain vibration throughout the whole mass, right? So similarly, for our case, we also have this shaft right through this mass, and when turned in a very fast speed, it will actually cause vibration throughout. There will be a force, okay, throughout, causing due to this shaft itself, right? So this is the problem. So how do we actually measure the force? How do we know the amplitude? Okay, so far in our course, what we have done is always about um, amplitudes, forces, summation of forces. If you remember, talking about summation of forces over here. So typically we want to describe a certain amplitude of the system, whether is it because the amplitude itself will describe how the system would behave. Will it be will the system move in a very terrible manner? And nonetheless, if you remember, we talk about the beta number. So hold on a When you talk about force vibration, you're talking about the beta. If you remember, this is the frequency compared with the natural frequency. So most of all, we want to really understand how these things will behave. If you still remember, so at this beta number one, the 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 it will go very unstable. So it will be the amplitude itself will actually zoom out in a very terrible manner. Nonetheless, this is not amplitude. Okay, I'm just trying to say that you can do things in terms of amplitude first, and then you can calculate certain stuffs. So nonetheless, you have certain phase angle, you have the beta and such. So nonetheless, we will actually do in terms of these things. So let's look at this system. Okay. So as you can see, we have a mass. Okay, and then this portion over here is being connected. Okay, I'm a little lagging. Okay, this portion over here. So you have to take a look in terms of 3D. You have this thing over here, right? Maybe I draw this too big. So maybe this is the mass, and then you have a rotating shaft that is connected. So there's a button there. There'll be a muffle over here, and then you start to turn. So this portion here will actually cause certain vibration due to the forces, the centrifugal force. It actually cause this whole mass to vibrate. You know, this whole thing will vibrate, as you can see in the video above, right? So as you can see at the below, there will be some damping system. Nonetheless, this damping system is actually some flexible rods. They are just trying to measure certain things within this rotation. So we can actually use this. You can actually find this thing, you know. But anyway, so how do we eventually tackle this problem? Why are we actually fighting? Okay, our end in mind is actually to derive an equation that so hold on. We eventually derive this equation, vibration measurement. Okay, so we try to measure the vibration of the system, right? How big it vibrates, you know. So as you can see also that is in terms of z over x. Okay, So this z over x is what it is. If you were to follow this formula over here, you actually write mx divided by me. This m is the mass of this mass. As you can see, this capital M is actually the system over here. Okay, and then actually this M is whole system over here. Sorry, this M is the whole system, while the x itself is the x measured from this distance. As you can see, we have a mx, right? So mx itself in the formula sheet is actually z, right? So you have to really be careful of that. So this is mx, and then and then nonetheless, the the mass itself, this mass itself is actually the mass of this whole thing over here. Okay, we're talking about this. You can say the whole piece over here, but let's just look at the 2D system. Okay, so this is mass. So we will be looking at two systems. One is actually this shaft itself. We call it mass in a small letter, while the metal piece, the one that connects to the shaft, we call this m minus m. Okay, so this m is the whole system, the mass of the whole system, while the m is, you know, so this one is called the um, non-rotating system. Okay, and this is the rotating system. So nonetheless, yes, you know the shaft will be rotating. So with this concept, we can actually use this thing to actually solve for our problems. So I will see you in the next video.